In this module, you will learn to find the mean deviation about the mean for grouped data. We know that data can be grouped in two ways: discrete frequency distribution and continuous frequency distribution. A collection of data consisting of distinct values occurring with certain frequencies is called discrete frequency distribution. Here is an example of discrete frequency distribution. The table displays the data of the performance of 50 students in a math test. In case of a large number of observations, we classify the data into different class intervals without any gaps along with their respective frequencies. Such distributions are called continuous frequency distributions. An example of continuous frequency distribution is shown here. The table displays the marks scored by 50 students. Let's begin with finding the mean deviation about the mean for discrete frequency distribution. Let x1, x2, x3, and so on, up to xn, be the n observations with frequencies f1, f2, f3, and so on, up to fn respectively. The mean x bar of the data is equal to the sum of the products of the observations and the respective frequencies, whole divided by the sum of the frequencies. Here n is the sum of the frequencies. Now, the deviations of the observations xi from the mean x bar is xi minus x bar, where I is equal to 1, 2, 3, and so on up to n. Next, we'll find the absolute values of the deviations. Finally, the mean deviation can be obtained by finding the mean of the absolute values of the deviations. This formula gives the mean deviation about the mean of a discrete frequency distribution. Let's consider the weights of 20 students. To find the mean deviation of the given data, we'll first find its mean. The sum of the products of the observations and the respective frequencies is equal to 1000. Therefore, the mean x bar is equal to 1000 divided by 20, which is equal to 50 kilograms. Let's find the modulus of deviation of each observation from the mean. Now, we'll find the sum of the products of the deviations of the observations and the frequency concerned, which is equal to 20. Therefore, the mean deviation about the mean is equal to 20 divided by 20, which is equal to 1. Next, we'll find the mean deviation about the mean of a continuous frequency distribution. Let's consider the frequency distribution shown here. In such cases, to find the mean of the data, we need to find the mid-values of the class intervals. Let's denote them by xi. Now, we'll find the product of the mid-values and their respective frequencies. The sum of the product of the mid-values and their respective frequencies is equal to 2600. Therefore, the mean x bar is equal to 2600 divided by 50, which is equal to 52. If the number of observations is large, then the mathematical calculations may be tedious. In such cases, we can use the assumed mean method or the step deviation method to calculate the mean. Next, we'll find the modulus of the deviations of the mid-values from the mean. Now, Find the product of the deviations with their respective frequencies. The sum of the products of the absolute values and their respective frequencies is equal to 768. Therefore, the mean deviation about the mean is equal to 768 divided by 50, which is equal to 15.36.